Hi everyone, my name is Andy,
Hi everyone, my name is Mitchell.
and this presentation is about mask detection algorithm. So we need effective strategies to defend ourselves against COVID-19 in order to avoid communal health and also individual health. Masks are one of the most effective ways in order to avoid getting infected and in order to analyze whether a person is wearing a mask or not without human observation. We can create a software that can detect masks on anyone. So the proposed technique is to assemble a facial recognition model that clarifies if a mask is being worn on or not, and we'll use two phases. We'll use a training phase, and we'll also use a deployment phase. The algorithm will be taken to classify mask compliance in real time without storing the images, and the results will demonstrate the accuracy of the model and also the ratio of mask to no mask on a single day.
Since the start of the pandemic in 2020, we spent the last 2 years wearing masks when attending classes. The university has implemented strict testing rules for students following these state guidelines. Although recently, on March 6, 2022, they finally lifted the COVID-19 testing rules for students who are fully vaccinated and boosted. The university still limits some areas on campus where it's mandatory to wear masks, being the Ramtram Health Center, classrooms, early childhood centers, McLaughlin Center, and Whitmore Library.
So we're going to conduct an experiment inside the athletic center on the Framingham State University campus so that we can measure the ratio of mask to no mask compliance, and we can measure the accuracy of the facial recognition model. We're going to be using open source softwares in 3 different time periods, which are 30 minutes each. And we're expecting the accuracy of the model to be fairly high coming into the experiment. We know there's going to be certain factors that's going to affect this, like the environment lighting, the angle, the resolution, the quantity, and the location of the mask on people's faces.
The way that we modified our model is through two open source softwares. The first being Lobe.ai, which is owned by Microsoft. It simplifies the process of machine learning into 3 easy steps. You train the model by uploading and labeling the images, and it will automatically train the model on a personal computer without any setup or configuration. It then understands the strengths and weaknesses of the model and shows you live results. The second software being unsplash.com, which is a repository of over 1 million free high-resolution photos. It grants copyright license to download, modify, distribute, perform, and use any photos from Unsplash for commercial purposes, and you don't need the permission of the photographer. Although this license does not include collecting images to replicate any kind of software that Unsplash uses.
So we're going to have two phases. The first one being the training phase. We're going to assemble a facial recognition model that clarifies if a mask is being worn on or not. And we're going to be studying the accuracy of the model and also the ratio of mask to no mask. We're going to save and download open source photos from unsplash.com inside of the computer. And we're going to be uploading images in order to train the model. The images are going to be divided into 25 mask and 25 no mask. And this image shows the sign that we used on the day of the experiment to tell students that we're going to be inside the athletic center measuring this.
For our deployment phase, we picked the location of the athletic center in Framingham State University. This image on the right demonstrates where we position the sensor. If you look very closely, you'll see a table and a couple of chairs. That's actually my computer right there, checking if people are wearing masks and no mask using the model. The times we picked were 9 a.m. to 9:30, 12 p.m. to 12:30, 3 p.m. to 3:30. The sensor being my MacBook Pro internal webcam. And for our experiment, we measured the results manually and automatically. The sensor detected masks and no masks, and the researchers kept track of the ratio and the accuracy of the model on paper.
So here's a column chart, basically describing different people wearing masks and different people not wearing masks and whether the machine detected them or not detected them. So for the blue, it's dark blue, it's mask detected. For light blue, it's mask not detected. For the dark red, it's mask no mask detected, and for the pink, it's no mask not detected. And we separated them into 3 different time sessions with the total. And on the y-axis, there's the amount of people that came in and out of the athletic center. So here, it's basically a summarized version in a table format. We have 3 different time sessions and a total. And we have a column for a mask, no mask, and a total. And we also decided to put the mask and no mask into percentages.
Here are 2 pie graphs demonstrating the accuracy of our model. The one on the left being from 9 a.m. to 9:30, and the one on the right being from 12 p.m. to 12:30. The green represents detected by the model, and the red represents undetected. And if you add both those together, you'll get the total amount detected during that time period and the total undetected by that time period. Here's another pie graph representing 3 p.m. And our total, and it's the same thing, detected and red being undetected.
So here's the summarization of the accuracy, but in a table format. It's separated by the time sessions and a row and a column just for the total. And for the columns, we have an accurate, inaccurate, and a total accuracy percentage. So for the factors that were affecting the accuracy of the model and the ratio, which were the result of the experiment, if we selected a more alternative model, or if we put more images into it, or if we allowed the model more time to train, that could have affected the accuracy and the results of our experiment. And for the ratio and the accuracy, the exposure of the sensor and the location of mask on people's faces, and the amount of sensors, and finally the amount of visitors, the amount of people that went in and out of the athletic center, all could have affected the ratio and the accuracy of the model.
So for our future implementations, we uploaded our software to TensorFlow, which is an open source software library for machine learning and AI. And then we uploaded that code into GitHub for anyone to use, and it's totally open source. We hope future research can be conducted in modifying our mask detection model and improve the overall accuracy. The software can be used in any environment. If any additional research can be conducted, it should take consideration of the previous factors in the previous slide. And we don't want our model to be used in any unethical ways, such as putting inside of security sensors or any kind of policy. And if you click this link right here at the bottom, it'll be our GitHub.
So for the references that we used, all these are different links and different titles that helped us with our experiment and our research overall.
Thank you guys so much. My information is at the top right, my name, my email, my LinkedIn, and my website.
And thank you. My name is Andy. All my information is on the top left in the same format as Mitchell's. And if you have any questions or concerns, you can contact us on our email address or LinkedIn. Thank you.